When most of Europe in the 17th century still believed the heavens were perfect, silent, and untouchable, a man lifted a strange tube of glass toward the sky and looked at the moon as though he were seeing the world for the first time. What he found was not the smooth, flawless celestial sphere taught in universities and defended by tradition. He found shadows, he found roughness, he found mountains. The moon, that ancient emblem of beauty and order, carried scars like the earth. Above all, it carried doubt. That doubt would become dangerous. For Galileo Galilei, the sky was never simply the sky. It was a battlefield of ideas, a place where faith, philosophy, power, and observation collided under candlelight and starlight. He lived in an age when knowledge was inherited more often than tested, when the great voices of the past still ruled classrooms, and when stepping outside the approved shape of truth could cost a man his reputation, his freedom, and the peace of his own soul. Yet Galileo kept looking, he kept measuring, he kept asking the sort of questions that make comfortable people uneasy and make history tilt. The central question of his life was never only whether Earth moved around the sun. It was larger, stranger, and far more human than that. It was this: what happens when one man sees something the world is not ready to believe? That question gave his life its drama. It gave his discoveries their force. It gave his enemies their fear. It gave his story the shape of a warning and the glow of a triumph. Galileo was not merely a scientist in the modern sense, calmly collecting facts in a sterile laboratory. He was the son of Renaissance Italy, a gifted teacher, a sharp-tongued polemicist, a patient observer, and a man who understood that every new truth enters the world wearing the costume of heresy before it is finally dressed in respectability. He lived at the fault line between old certainty and new sight. The world he inherited was vast in authority and narrow in imagination. The earth stood still at the center. The heavens moved in perfect circles. The cosmos was supposed to be a polished machine whose design reflected divine order. Human beings occupied the middle, secure in the belief that creation had arranged itself around them. But Galileo's eyes kept finding imperfections. The moon was not smooth. The sun was not spotless. Jupiter had companions. The universe did not behave like a closed and finished artwork. It behaved like something alive, restless, and still being read. That is why his story remains so powerful. It is not only the story of a man who looked through a telescope. It is the story of what happens when looking becomes a form of rebellion. It is the story of a mind that refused to worship appearances and of a civilization that had to decide whether it would protect inherited certainty or face what was shining in front of it. Galileo's life moves with the force of a great narrative because every stage changes the stakes. At first, he is only a curious boy in Pisa. Then he becomes a mathematics professor, then an ingenious experimenter, then a maker of instruments, then a discoverer, then a public voice, then a defendant, then an old man under house arrest whose body is confined even as his ideas escape into the future. Each stage narrows the circle around him while expanding the world beyond him. The more he sees, the more he risks. The more he speaks, the more the world pushes back. The more the world pushes back, the more certain he becomes that truth does not require permission. His life also has a visual shape. It belongs to candle-lit rooms, darkened chambers, tower stairs, velvet-clad courts, university halls, and cold open skies. It belongs to maps with cities marked by competing loyalties. It belongs to timelines where the old universe and the new one overlap for a dangerous moment before one begins to replace the other. It belongs to simple images: a ball rolling down a slope, a lamp swinging in a cathedral, a lens catching light, a hand shading the eyes, a star that should not be there, a courtroom where silence matters more than shouting. These are not just scenes, they are turning points, and beneath all of them lies the deeper tension that made Galileo unforgettable. He was not a saint of modern science, untouched by ego or pride. He could be brilliant and difficult, patient and mocking, fearless and reckless. He was admired, envied, protected, and attacked. His gifts opened doors, but his character sometimes slammed them. That human complexity matters, because the story of Galileo is not a simple march of reason defeating ignorance. It is messier, more dangerous, and more revealing. It is the story of how truth advances through friction and how those who carry it often pay for the privilege. To understand Galileo, then, is to enter a world where the sky itself becomes a question mark. The old order looks solid until someone examines it closely enough to notice its cracks. A professor becomes a troublemaker. A device meant to improve navigation becomes a machine for unsettling the universe. A quiet night of observation becomes the beginning of an argument that will echo for centuries. And that is where the story begins, in a world that believed it already knew its place, before one man dared to look higher, closer, and more honestly than anyone had done before. But before Galileo steps into the center of the story, the world around him must first come into view. His discoveries did not arrive in a vacuum. They burst out of a culture already crowded with authority, anxiety, and expectation. Europe was not waiting calmly for a new idea. It was holding tightly to the old ones, and for good reason. Those old ideas had organized classrooms, churches, courts, and entire ways of imagining the cosmos. If they fell, then more would fall with them than a theory about the stars. A whole intellectual order would begin to tremble. So the story has to widen before it can narrow. It has to begin with the universe Galileo inherited, because only then does the force of his rebellion become visible. The next chapter turns to that earlier world, when Earth sat still in the center of existence, when the heavens were thought to be perfect, and when the cost of disagreement was measured not only in arguments, but in authority, identity, and fear. Galileo will soon enter that world as a boy, but first, the world itself must be seen as he would later challenge it. Massive, confident, and wrong. Prior to Galileo ever looking through a telescope, before his name became sharp enough to split centuries in two, he inherited a universe that seemed settled, polished, and immovable. It was a world designed to reassure. The Earth rested at the center like a throne. Above it, the moon, the planets, and the stars moved in layered, elegant motions that scholars had traced and retraced for generations. The heavens were not only beautiful in this view, they were supposed to be perfect. They were supposed to be beyond corruption, beyond change, beyond the messy, unfinished quality of life on Earth. That belief gave people a kind of order they could feel in their bones. The sky was not random. It had structure, it had purpose. It reflected hierarchy, and hierarchy mattered in the world Galileo was born into. Kings ruled because the world was ranked. Fathers ruled because the household was ranked. The church spoke with authority because truth itself was ranked. Above all of them stood a cosmos that seemed to confirm the arrangement. Earth at the center was not just a scientific claim. It was a statement about human importance. In the schools, the great names of the past still carried immense weight. Aristotle remained a giant presence, his ideas woven into the texture of learning. Ptolemy's model of the universe had been refined over centuries, becoming less a theory than a habit of thought. When scholars looked upward, they did not begin with the question of what the sky might actually be doing. They began with what respected authorities had already said it must be doing. Knowledge was often treated like inheritance. One received it, repeated it, defended it, and passed it on. The result was a world that could be intellectually rich and intellectually enclosed at the same time. Universities, especially in Italy, were alive with debate, but much of the debate took place inside walls that had already been built. Students learned to argue by starting from accepted foundations. To question the foundations themselves was a different matter. That kind of doubt could make a man appear careless, arrogant, or dangerous. It could turn a promising mind into an inconvenient one. Outside the lecture halls, the broader world was changing in ways that made certainty both more valuable and more fragile. Renaissance Europe was crowded with motion. Trade routes carried wealth and ideas. Printing spread arguments faster than ever before. Cities like Venice and Florence glittered with artistic brilliance, political maneuvering, and intellectual hunger. Old loyalties still mattered, but new ambitions were everywhere. Merchants wanted practical knowledge, navigators needed accurate charts, engineers needed better measurements. Artisans wanted devices that would widen the reach of the hand and sharpen the reach of the eye. This was the hidden pressure beneath the old universe. It was not collapsing yet, but it was being tested from below. Imagine a simple map of Europe in this period. Italy sits like a bright chain of city-states, each one proud, competitive, and alert. Venice faces the sea and measures the world by commerce. Pisa carries the memory of earlier prestige. Florence burns with artistic and intellectual confidence. Rome stands as the gravitational center of spiritual authority. Between them all move scholars, clerics, patrons, and craftsmen, each carrying different expectations of what knowledge should do. Some wanted wisdom, some wanted prestige, some wanted power, some wanted tools that worked. That tension mattered because Galileo's life would unfold right where those interests overlapped. He was not born into a quiet age of pure theory. He was born into a civilization that expected knowledge to serve something. A theory was never just a theory. It could elevate a patron, embarrass a rival, strengthen a court, threaten a doctrine, or unsettle a carefully balanced order. The visual world of this era also mattered. Light and shadow were not abstract concerns. They shaped how people understood everything. In churches, candle flames trembled across painted saints. In palaces, polished surfaces reflected rank and wealth. In workshops, metal, glass, and wood were shaped by hand. In observatories and private studies, the simplest instrument could alter what a man believed himself to see. The era was full of thresholds. Doors opened onto courtyards, balconies overlooked crowded streets, and towers reached toward a sky still considered sacred and remote. The heavens, in this old view, were not a place to be inspected like a marketplace or an instrument bench. They were a realm to be contemplated with reverence. That difference in posture is crucial. Reverence asks for humility before truth already declared. Observation asks for humility before truth not yet known. Galileo's life would belong to the second kind of humility, though he would spend much of it fighting people who believed the first was enough. At the center of the old universe stood a powerful emotional promise. If everything was ordered from the heavens downward, then human life was part of a stable design. Suffering had meaning. Place had meaning. Obedience had meaning. The universe did not have to be understood in every detail because its broad outline already made sense. Earth was where change, decay, and imperfection lived. The sky was where perfection remained untouched. That distinction gave comfort to rulers, scholars, and believers alike. But comfort can become a cage. The problem with a perfect cosmos is that it leaves little room for surprise, and surprise is exactly what the early modern world was beginning to produce. New instruments were extending human senses. Better mathematics was exposing weaknesses in older calculations. Observers were becoming less willing to accept claims that could not be checked. Slowly, almost imperceptibly at first, reality was becoming something a person might test rather than merely receive. That shift was not small. It was transformative. A civilization built on inherited order was beginning to feel the pressure of direct experience. The old universe had been held together by authority, but authority alone could not stop a careful eye from noticing a crack. And somewhere in Tuscany, far from the grand arguments of Rome and the philosophical certainties of ancient texts, A boy was growing up in a household where hard questions were not entirely unwelcome. He did not yet know that he would become one of the men who made the old cosmos unstable. He did not yet know that his name would one day be spoken as a symbol of scientific courage and institutional conflict. He only knew that the world was larger than it seemed, and that appearances were often too neat to be trusted. That instinct would matter more than anyone could yet imagine. Because the old universe was still standing, its walls were still intact, its defenders were still confident. But confidence can be misleading when the first hairline fractures have already begun to spread. The world Galileo inherited was full of authority, but authority alone does not explain a man who learns to doubt it. For that, the story has to move closer, from the broad shape of Europe down to one household, one boy, and one atmosphere of family tension and intellectual hunger. The next chapter turns away from the grand structure of the cosmos and into the smaller, more intimate world that helped make Galileo who he became. There, in the streets and schools of Pisa, a future troublemaker of the heavens begins as something far simpler and far more human. A son, a student, and a restless mind learning very early that the easiest answer is rarely the most interesting one. Galileo Galilei did not enter the world as a challenger of the heavens. He arrived in Pisa in 1564 as the son of a musician, a family name that carried more skill than wealth, more creativity than security. Nothing about his birth suggested that he would one day unsettle the foundations of European thought. He was not born into grandeur. He was born into motion, into music, mathematics, trade, and the practical pressures of making a life in Renaissance Italy. His father, Vincenzo Galilei, mattered more to Galileo's mind than any university at first. Vincenzo was not a man of blind tradition. As a musician and theorist, he questioned inherited rules of harmony and sound, arguing that experience mattered more than ancient authority. In a world still dominated by reverence for the old masters, that attitude was quietly radical. Without knowing it, Galileo grew up inside a household where disagreement with tradition was not rebellion, it was craft. That environment shaped something subtle in the boy, not certainty, but suspicion, not defiance, but curiosity that refused to settle. Pisa itself added its own influence. It was a city of stone and echo, once powerful, now slightly faded, its streets filled with students, merchants, and teachers who carried the weight of learning like an inheritance that could be either respected or questioned. The famous Leaning Tower already tilted against the sky like a frozen question mark, as if the city itself had learned to accept instability. In childhood, Galileo did not begin with grand theories. He began with observation. He noticed movement. He noticed rhythm. He noticed how things behaved when no one was trying to interpret them. That habit would later become his signature, a refusal to accept explanations that did not match what the world actually did. Education, however, was not designed to reward that instinct. It was designed to discipline it. When Galileo was sent toward formal study, he entered a system built on inherited knowledge. Medicine was considered the noble path. Mathematics was useful but secondary, something closer to a tool than a calling. His family hoped he would pursue stability, not abstraction. Stability meant medicine. Medicine meant respectability. Respectability meant survival in a society where intellectual identity could determine a man's entire future. But Galileo's attention drifted elsewhere. In quiet moments, he watched how objects fell, how they moved, how they resisted assumptions. He noticed that reality did not always behave the way textbooks suggested. This was not yet revolution. It was irritation, small, private friction between what was taught and what was seen. There is a particular kind of moment in intellectual life that often goes unnoticed in grand histories. It is not discovery. It is not argument. It is the silent realization that something does not add up. For Galileo, those moments began accumulating early. A lamp swinging in a cathedral, a ball rolling along a surface. The simple act of measurement revealing that motion was more consistent than explanation allowed. He did not yet have language for what he was noticing, but he was learning a crucial habit: trust the world more than the reputation of the explanation. At the University of Pisa, that habit became harder to hide. The university was a place of structured thought, where ancient authorities still shaped lectures. Students learned how to reason within established frameworks rather than dismantle them. Professors did not simply teach information, they transmitted intellectual lineage. Aristotle was not just studied, he was treated as a foundation stone. Galileo, however, had a difficult relationship with foundations that refused to be examined. He began to question, sometimes quietly, sometimes openly. He did not always present himself as diplomatic. He had a sharp tongue and a tendency to expose weaknesses and argument with uncomfortable clarity. In a classroom, that kind of mind is both admired and feared. It can make a student visible in a way that is not always safe. One of the most famous stories associated with this period, whether entirely precise in detail or shaped by later retelling, captures something essential about him. It describes Galileo observing objects of different weights being dropped and noticing that their behavior did not align with accepted teachings. The point is not only the experiment itself, but the instinct behind it. A willingness to let physical reality speak louder than inherited authority. For his teachers, this was unsettling. For Galileo, it was simply obvious. Yet the world he lived in did not reward obvious when it contradicted tradition. It rewarded alignment. And Galileo was not particularly interested in alignment, unless it was with truth as he could observe it. Outside the university walls, Pisa itself carried a different kind of lesson. It was a city that remembered its former strength, but lived in a quieter present. That contrast mattered. It suggested that even institutions could shift over time, that nothing remained fixed forever, not cities, not knowledge, not authority. Galileo absorbed this atmosphere without announcing it. Ideas rarely enter minds with noise. They accumulate. As he moved between study and observation, between expectation and curiosity, a tension began to form inside him. It was not yet a philosophy. It was not yet a worldview. It was a pattern of discomfort whenever explanation outpaced evidence. That pattern would follow him for the rest of his life. At this stage, he was still expected to become a doctor. His family needed him to choose stability. Society expected him to choose usefulness. But Galileo was already developing a different kind of usefulness, one that did not yet have a name. He was learning how to see. And in a world that trusted inherited vision more than direct sight, that ability would eventually become dangerous. In Pisa, Galileo's mind had begun to separate itself from expectation, but it had not yet found its full direction. He was a student, a son, and a developing thinker, still shaped by institutions that could both nurture and restrict him. What came next would push him out of the comfortable uncertainty of student life and into the sharper world of teaching, argument, and intellectual rivalry. Next, we follow him as he steps into adulthood, where ideas are no longer private curiosities, but public positions, and where every claim about the world begins to carry consequences he is not yet fully prepared to face. Galileo did not become a revolutionary the moment he left Pisa. He became something more subtle first. A man learning how to survive inside the very system he was beginning to question. When he stepped into the world of teaching, He entered adulthood not as a conqueror of knowledge, but as its interpreter. Mathematics became his language, not because it was fashionable, but because it was precise enough to feel honest. In a Renaissance Italy still dominated by philosophical inheritance, mathematics offered something rare. Statements that did not depend on who had spoken them first. He moved between universities and intellectual circles like a man testing different acoustics, listening for where his voice carried clearly and where it was absorbed by old stone walls. Pisa had shaped his curiosity. Now other cities would shape his reputation. Padua, in particular, became a turning point. It was a city alive with students from across Europe, a place where ideas moved almost as quickly as trade. The university there was less rigid than Pisa, more open to practical thinking, more willing to tolerate experimentation. If Pisa had taught Galileo suspicion, Padua gave that suspicion room to grow into method. He began teaching mathematics publicly, a position that did not carry the prestige of philosophy or medicine, but carried something more important: independence. Mathematics did not require permission from ancient authorities to function. It either worked or it did not. That distinction changed him. In his lectures, Galileo did not simply repeat inherited knowledge. He tested it against logic, against geometry, against physical intuition. He was not always gentle in how he did this. His confidence could be sharp, even abrasive, especially when he sensed weakness in arguments that others treated as untouchable. Some students admired this clarity. Others found it unsettling. Professors who preferred stability over disruption found it increasingly difficult to ignore him. But the most important transformation was not social. It was internal. Galileo began to realize something that would quietly redefine his life. That the world could be described in more than one way, but only one way consistently matched what could be observed. That realization sounds simple in hindsight, but in his time, it was disruptive. It suggested that authority and accuracy were not the same thing. He started paying closer attention to motion. Not motion as philosophy, but motion as experience. A ball rolling down a slope, a weight swinging from a fixed point, a falling object tracing a path through air. These were not abstract problems for him. They were questions waiting to be measured. He would often construct informal demonstrations, watching how objects behaved under controlled conditions. He was less interested in what ancient texts said about motion and more interested in what motion actually did when no one interfered with it. In this way, Galileo slowly began replacing argument with observation, and observation with repeatability. This shift did not make him popular in every academic circle. In the intellectual culture of the time, to challenge established thought was not simply to disagree. It was to risk appearing arrogant, even reckless. Knowledge was tied to reputation. Reputation was tied to hierarchy. And hierarchy was tied to stability. Galileo's growing tendency to test rather than defer placed him increasingly at odds with those who saw their role as guardians of inherited wisdom. There were moments when he could have chosen a safer path. He could have softened his claims, framed his ideas more cautiously, avoided confrontation. But something in him resisted that compromise. Not because he sought conflict, but because he could not unsee what he had observed. And once observation enters a mind like his, it rarely leaves quietly. Outside the lecture halls, Galileo's life was still ordinary in many ways. He faced financial pressures. He navigated patronage systems that determined whether a scholar could continue his work or fade into obscurity. He understood, perhaps more than he admitted, that ideas alone were not enough. They needed protection, sponsorship, and timing. This is one of the quieter tensions in his life. The space between intellectual independence and practical dependence. He wanted freedom to think, but he lived in a world where thinking itself often depended on those with resources. Still, his reputation grew. Not as a philosopher in the traditional sense, but as someone who could make mathematics feel alive. Something tied to the physical world rather than locked inside abstract reasoning. That distinction would prove crucial later, when his attention shifted from motion on Earth to motion in the sky. Because even now, without yet owning the instrument that would define his legacy, Galileo was already developing the most important habit of his career, the refusal to separate mathematics from reality. The world, for him, was not an idea first and a place second. It was a place that could be measured and therefore understood differently than tradition allowed. And slowly, almost without announcement, another change was approaching. Not in his lectures, not in his reputation, but in the wider world of tools and perception. A change that would extend human sight beyond its natural limits and pull Galileo from the ground into the sky. For most of Galileo's early life, the universe had remained an object of thought rather than direct inspection. The stars were distant symbols, the planets moving according to inherited models. The heavens described more than they were seen. Even his growing attention to motion still belonged to Earth, to slopes, weights, pendulums, and physical experience within reach of the hand. But in the early 17th century, something began to change the boundary between what could be imagined and what could be seen. A simple optical invention, first treated as a curiosity for distant ships and military advantage, was about to become something far more unsettling. A device that extended the human eye itself. When Galileo first encountered it, it would not yet be a tool of science. It would be a novelty, a trick of glass and distance, a device meant to bring the far closer, but in his hands, it would become something else entirely. Let's start at that moment of contact, when a man who had learned to trust observation more than authority finally gains an instrument that allows him to see farther than anyone had ever seen before, and discovers that the sky is not waiting to be admired, but waiting to be questioned. At first, it did not belong to science at all. The device that would transform Galileo's life entered his world like a curiosity from a workshop, not a revelation from nature. It was a tube of glass and lenses, crude by later standards, unstable in focus, imperfect in clarity, used mostly for practical advantage. Merchants could glimpse approaching ships earlier. Soldiers could study distant movements on the battlefield. It was a tool of distance, designed for survival and strategy, not for philosophy. In its earliest form, it was not even treated with respect. It was a trick of perspective, something amusing, something useful, something unrefined. But Galileo saw it differently. When he first learned of the instrument, he did not dismiss it as novelty. He studied it, he rebuilt it, he refined its lenses with the patience of a craftsman and the mind of a mathematician. While others were satisfied with what it could do, he became interested in what it could reveal if pushed beyond its intended limits. In his hands, the instrument changed from a curiosity into a question. What if the eye itself could be extended? What if distance was not a barrier, but a problem of precision? He began constructing his own versions, improving magnification with careful grinding, adjusting curvature, testing clarity. Each adjustment brought the world a little closer, but more importantly, it revealed something unexpected. The world did not behave differently when seen more closely. It only appeared more complicated. At first, he used it in the same way others did, pointing it toward distant landscapes, ships at sea, objects on the horizon. But those early tests quickly became less interesting to him than what lay above. Because the sky, long treated as distant perfection, was suddenly within reach. And that shift, psychological as much as optical, changed everything. On a clear night in northern Italy, Galileo raised the instrument toward the moon. What he expected, like everyone else trained in the old world view, was smoothness, purity, a surface unmarred by imperfection. The moon was supposed to be a perfect celestial sphere, untouched by the roughness of Earth. But the image that returned through the glass refused to behave. The moon was not smooth, it was uneven, textured, broken by light and shadow in ways that resembled terrain rather than perfection. There were dark regions and bright regions, irregular boundaries between illumination and darkness. And as Galileo observed more carefully, those patterns began to resemble something familiar. Mountains, valleys, a landscape. For a long time he watched in silence, not because he did not understand what he was seeing, but because understanding it carried consequences that reached far beyond astronomy. If the moon had mountains, then the old division between earth and heaven was no longer clean. The universe was no longer neatly separated into perfect above and imperfect below. The boundary had begun to dissolve. The telescope did not simply show him more. It changed the meaning of what was seen. He began sketching what he observed, translating light and shadow into diagrams that could be shared, examined, and argued over. These were not decorative illustrations. They were claims. Each mark on the page suggested that the sky was not a flawless structure, but a physical place. In Renaissance visual culture, this mattered deeply. A map was not just a drawing, it was a statement about reality. To redraw the heavens was to redraw the order of existence itself. And Galileo was beginning to do exactly that. But the moon was only the beginning. As he continued to refine his instrument and extend his observations, he turned it toward other parts of the sky. What he found there would intensify everything he had begun to suspect. Because the universe was not only imperfect, it was populated in ways no inherited model had predicted. And with each new observation, the distance between what had been believed and what was now visible began to shrink. Not gradually, but decisively. The moon had already broken the illusion of perfection, but it still allowed room for interpretation. Even imperfections could be argued about, explained away, or absorbed into revised philosophical systems. What Galileo had seen was disturbing, but not yet fatal to the old universe. That would change with the next discovery. Because when he turned his telescope away from the moon and into the deeper darkness of space, he did not find a simple extension of known patterns. He found something entirely new. Objects that should not have existed under the old model at all, moving in ways that directly contradicted the assumption that everything in the heavens revolved around Earth. And unlike the moon's surface, these were not static features. They moved, they changed position. They revealed a rhythm that belonged to something other than Earth itself. As Galileo encounters the discovery that begins to fracture the center of the universe, he does so not by argument, but by motion. The first great shock did not come from a planet or a star. It came from the moon, hanging pale above Italy, like something everyone thought they already understood. For centuries, the moon had carried an almost ceremonial role in the imagination of Europe. It was close enough to be seen clearly, yet distant enough to remain mysterious. It belonged to the heavens, and the heavens were supposed to be clean, serene, and untouched by the disorder of Earth. The moon was not meant to have texture. It was not meant to have edge. It was not meant to resemble a landscape. Yet Galileo kept looking. Night after night, he traced the boundary between light and darkness across its face. He watched how the shadow line shifted. He noticed that certain bright points seemed to catch the sun's light before the surrounding surface did, as if tall forms were rising out of darkness. He observed that the illuminated edge was not smooth but jagged, uneven, full of suggestion. He did not merely glimpse a bright object in the sky. He read it the way a surveyor might read a coastline. And slowly, then suddenly, The moon stopped being a symbol and became a place. This mattered because the old universe had depended on a clean separation between Earth and heaven. Earth was changeable, flawed, heavy, and imperfect. The sky was supposed to be the opposite, pristine, eternal, incorruptible. If the moon had mountains, then that division was no longer secure. The heavens were not made of a different kind of substance from the earth. They were not sealed away in perfection. They were physical, textured, and vulnerable to the same scrutiny as everything else below them. Galileo understood the implications at once, even if he did not announce them with dramatic flourish. This was not merely a poetic discovery. It was a structural one. It was as though a wall thought to separate two worlds had begun to crack, and through the cracks, the same rough material appeared on both sides. He sketched what he saw. He measured the play of light and shadow. He translated observation into images that other minds could inspect. The drawings mattered because they were portable forms of seeing. A person in one room could look at Galileo's page and, in a sense, stand beside him under the same night sky. The sketch became a bridge between private sight and public challenge. The main force of this moment lies in how quiet it was. There was no thunderclap, no royal decree, no sudden uproar in the streets. The sky simply refused to remain what tradition said it was. The moon, by existing with visible roughness, began to overthrow an older philosophy one measured shadow at a time. But Galileo was not done. The telescope had taught him that the world could look different when seen more closely. Now he aimed it farther outward, toward the deeper architecture of the cosmos. If the moon could be flawed, what else might be waiting to contradict the old certainties? So he turned to the stars. There, in the dark space near Jupiter, he noticed something strange. At first it seemed insignificant, the kind of detail a lesser observer might ignore. Tiny points of light appeared near the planet. Over successive nights, their positions changed. They did not stay fixed. They shifted from one side of Jupiter to the other, then reappeared in different arrangements, as if circling an invisible center. Galileo watched carefully. He compared one night with the next. He measured, noted, and returned again. The pattern remained. These were not distant stars. They were companions to Jupiter. The realization struck with devastating simplicity. Not everything in the heavens moved around Earth. This discovery did more than challenge a model. It punctured an assumption that had supported the model emotionally and philosophically. Earth was no longer the obvious center around which all things revolved. There was at least one other miniature system in the sky, a planet with its own attendants, its own small architecture of motion. The universe had multiple centers of activity, multiple patterns of order. Earth was not alone in commanding celestial company. For the old worldview, this was profoundly unsettling. For Galileo, it was exhilarating and dangerous at once. He was not just looking at new objects. He was discovering a new principle, that the universe did not revolve around a single fixed human point of reference. That principle would eventually reshape astronomy. But in this moment, it existed as a quiet series of observations under a winter sky, each one sharpening the edge of a much larger argument. The emotional force of the scene rests in that contrast. To a casual observer, the stars near Jupiter were tiny and easy to miss. To Galileo, they were destabilizing. The smallest things in the sky were exposing the largest weakness in the old universe. And once he had seen it, he could not unsee it. He was building not only an astronomical case, but an intellectual trap for the old order. Every new observation narrowed the space in which the old explanations could survive. The moon was rough. Jupiter had moons. The heavens were not simple. The center was not unique. In a culture that had long trusted visual perfection, Galileo's telescope had become a machine for introducing imperfection into certainty. It had not destroyed the old cosmos all at once. It had made it look vulnerable. That vulnerability mattered because ideas live or die not only by whether they are true, but by whether they can survive pressure. Galileo had begun applying pressure, and the cosmos under his lens was starting to yield. The discoveries around Jupiter changed the terms of the argument. The old universe was no longer merely being questioned in theory. It was being contradicted by motion, by pattern, by the evidence of the eye itself. Yet the most unsettling part of Galileo's work was not only what he found in the night sky. It was what happened when he began looking at the brightest and most revered object in the entire system. The sun, long imagined as flawless and untouchable, was about to reveal marks of its own. And that revelation would deepen the crisis, because a sky with mountains and moons could perhaps still be explained away by a clever defender of tradition. A sun with blemishes would be much harder to dismiss. The next chapter follows Galileo into a discovery that turned light itself into evidence, and evidence into danger. If the moon had cracked the illusion of perfection, the sun threatened to shatter it completely. For centuries, the sun had occupied a near-sacred position in the structure of the heavens. It was not merely a physical body in the sky, it was a symbol of purity, constancy, and divine order. In the old cosmology, celestial bodies were supposed to be incorruptible. They did not decay, they did not stain, they did not change in the way earthly things changed. The sun, more than anything else, embodied that idea of permanence. To suggest otherwise was not just incorrect, it was almost unthinkable. And yet Galileo kept watching. By now, the telescope was no longer a novelty in his hands. It had become a disciplined extension of his senses. He no longer pointed it casually. He tested angles, he filtered light, he studied conditions. The sun, however, presented a problem even observation could not solve easily. To look directly at it through glass was dangerous. So Galileo adapted, using techniques to reduce its intensity, carefully controlling how its light entered the instrument. What he saw through that filtered brightness unsettled him. Dark markings appeared across the sun's surface, irregular, shifting, transient. They were not fixed imperfections like scars carved into stone. They moved, they changed shape, they emerged, drifted, and disappeared over time. Sometimes they clustered. Sometimes they spread, sometimes they faded into nothing, only to reappear later in different positions. At first, he recorded them cautiously, as if waiting for confirmation that what he was seeing was not an illusion of optics or atmosphere. But the pattern persisted. These were not random distortions. They were consistent features that followed the sun's rotation. And that was the crucial realization. The sun itself was changing. This discovery carried a quiet violence against the older universe. If the sun had spots, then it was not perfect. If it changed, then it was not eternal in the way tradition assumed. If it rotated, then it behaved like a physical object rather than a flawless celestial emblem. In one set of observations, Galileo had taken a symbol of divine constancy and revealed it to be dynamic, imperfect, and material. The emotional weight of this moment is easy to underestimate from a modern perspective. Today, sunspots are routine knowledge. In Galileo's world, they were philosophical rupture points. They suggested that the boundary between earth and heaven was not just blurred. It might not exist in the way people had believed at all. Galileo did not treat this lightly. He compared observations over days and weeks, tracking movement across the solar disk, documenting recurrence, noting patterns of rotation. The sun was not only marked, it was behaving like a world. And if it was a world, then it belonged on the same side of reality as Earth. This was where observation and consequence began to merge. Each new discovery no longer stood alone. They began to form a chain. The moon showed imperfection. Jupiter showed independent motion. The sun showed change. Together they pointed toward a single implication. The heavens were not fundamentally different from Earth. They were part of the same physical system. That idea did not announce itself as a slogan. It emerged slowly, like a pressure building behind a wall. Outside Galileo's study, however, the world did not reorganize itself to match his findings. Institutions do not shift easily. Universities, religious authorities, and philosophical traditions had invested centuries into a structured cosmos. That structure was not just intellectual. It was emotional, cultural, and spiritual. To revise it would require more than evidence. It would require surrendering a way of understanding humanity's place in existence. And Galileo, increasingly, was no longer only an observer. He was becoming a voice. He shared his findings. He wrote about them. He demonstrated them. He allowed others to look through his telescope and see for themselves. This was a crucial part of his method, even if it created tension. He was not asking people to trust him blindly. He was asking them to trust what they could see. But seeing, in this context, was not neutral, because what people saw challenged what they had been taught to believe. The sun with spots was not just an astronomical detail. It was a philosophical intrusion. It suggested that authority could be corrected by observation. It suggested that inherited certainty might be incomplete. It suggested that the universe was still open to revision. And that suggestion was far more unsettling than any single spot on the sun. Galileo was beginning to realize that he was not simply collecting discoveries. He was accumulating contradictions. Each one pressed against the old framework a little harder. Each one reduced the space in which the traditional cosmos could remain stable. Yet he had not yet reached the most dangerous implication of all. Because if the heavens were imperfect, and if celestial bodies behaved like physical worlds, then the question was no longer just about what the universe looked like. It was about where Earth itself belonged within it. And that question, once fully formed, would shift Galileo from observer to challenger in a way that would reshape his life entirely. The sun's imperfections had already shaken the idea of celestial perfection, but they still allowed room for debate. Even sunspots could, in theory, be explained away by those determined to defend the old model. The cosmos was becoming more complicated, but not yet fully displaced. That final displacement would require a more direct challenge to the structure of the universe itself, its architecture of motion, its assumed center, and the belief that Earth occupied that center by necessity. Galileo was approaching that threshold. And when he crossed it, he would not merely be adjusting details within an existing system. He would be stepping into a conflict over the very shape of reality, where observation no longer simply described the world, but began to redefine it entirely. By now, Galileo's nights were no longer simple acts of curiosity. They had become disciplined encounters with a universe that refused to stay within the boundaries of inherited belief. Each observation carried the weight of a question that could not be unasked. If the moon was imperfect and the sun was marked, what else in the heavens had been misunderstood? Yet even with those revelations, the structure of the old cosmos still held its most powerful assumption intact. Earth, it claimed, remained still at the center of everything. The heavens might be more complicated than expected, but they still revolved around humanity's fixed point of reference. That idea was so deeply embedded in philosophical, religious, and scientific thinking that it did not feel like a theory. It felt like reality itself. Galileo turned his attention further outward. Jupiter had already revealed something unsettling. Small wandering points of light that behaved like companions rather than distant stars. But now, he began tracking them more carefully, night after night, refining his observations into a pattern that could not be dismissed as coincidence or illusion. What emerged was not random motion, but order. These points of light, later understood as moons, shifted positions in a consistent rhythm around Jupiter. Sometimes they appeared on one side, sometimes on the other, sometimes hidden from view altogether, as if eclipsed by their parent planet. Their behavior followed a predictable structure that could be recorded, compared, and anticipated. Galileo did not simply see movement, he saw system. And that system carried an implication that struck at the heart of everything the old cosmology depended on. If Jupiter had its own orbiting bodies, then not all celestial motion revolved around Earth. This was not a philosophical suggestion. It was an observational fact, repeated across multiple nights of careful study. The universe was not composed of a single central structure with everything obediently circling Earth. It contained multiple centers of motion, multiple layers of order, multiple local systems operating within a larger whole. To someone raised in the older model, this would have felt like intellectual disorientation. To Galileo, it felt like clarification. The sky was not chaotic. It was structured, but not in the way tradition had assumed. He documented everything with increasing precision. His sketches of Jupiter and its moons became a kind of visual argument, a way of translating motion into evidence that others could inspect. In these drawings, Jupiter appeared as a steady anchor, while small points shifted around it in measured progression, like dancers around a stage that was itself moving through space. The simplicity of the image made its implication more powerful. It did not require abstract reasoning to understand. It required only attention. And attention, once trained properly, became difficult to reverse. This is where Galileo's work began to take on a different kind of force. It was no longer just about what he saw. It was about what others could see if they were willing to look through the same instrument. The telescope became more than a device. It became a test of intellectual courage. Many who were invited to observe through it experienced a kind of hesitation, not because the image was unclear, but because clarity itself was destabilizing. It is one thing to hear that a model of the universe has changed. It is another to witness that change directly in the sky. Galileo understood this tension. He also understood that evidence alone does not immediately reshape belief. People interpret what they see through the framework they already trust. And the old framework was still powerful, but the accumulation of contradictions was becoming difficult to ignore. The moon showed Earth-like terrain. The sun showed change. Jupiter showed independent motion. Each discovery chipped away at the assumption that Earth occupied a unique and privileged position in the cosmos. The universe was not confirming hierarchy. It was revealing plurality. And plurality carried consequences. Because if Earth was not the center of everything, then humanity's place in the cosmos required reconsideration, not as a minor adjustment, but as a structural revision of identity itself. Galileo did not always frame it that way publicly. He was careful, strategic, and aware of the tensions surrounding his work. But intellectually, the direction was clear. The old universe was no longer sufficient to explain what was being observed. And the more he looked, the more the center seemed to move away from Earth entirely. Not abruptly, but unmistakably. The discoveries around Jupiter marked a turning point, but they still existed within a world that could, at least in theory, be defended through revision rather than replacement. The idea of multiple centers of motion could be debated, interpreted, or absorbed into modified versions of the old system. But there was another idea already circulating in Europe, older than Galileo's telescope, yet now gaining new force under his observations. It proposed something far more radical than multiple systems of motion. It suggested that Earth itself might not be still at all. That idea, associated with the Copernican model, did not simply adjust the structure of the heavens, it moved the foundation beneath them. And once Galileo began to seriously engage with it, the question would no longer be whether the heavens were imperfect or complex. It would become whether humanity had been standing in the wrong place the entire time. For most of Galileo's life, Earth had been the one certainty no one felt required to prove. Everything in the sky might be debated, refined, or reinterpreted, but Earth itself solid, unmoving, dependable, stood as the fixed point around which all explanation rotated. It was not just a scientific assumption, it was an emotional anchor. A still Earth meant a stable universe. A stable universe meant a meaningful human place within it. But ideas do not remain still when evidence begins to pull at them from different directions. By the time Galileo turned his attention more seriously toward the cosmological model proposed by Nicholas Copernicus, he was no longer dealing with isolated anomalies. He was standing in the middle of a growing pattern. The moon had revealed a physical surface. The sun had revealed change. Jupiter had revealed independent motion. Each discovery weakened the idea that everything circled Earth by necessity. Copernicus offered something far more unsettling, a different center entirely. In this model, Earth was not the fixed heart of creation. It was one planet among others, moving through space, carried by motion it did not feel. The Sun, not Earth, occupied the central position around which the known planets revolved. The idea was elegant in mathematical form, but in lived imagination it was disorienting. Galileo did not immediately present himself as a public champion of this system. He approached it cautiously, intellectually. The Copernican model was not yet universally accepted, and in many circles it was treated as a useful calculation tool rather than a literal description of reality. To treat it as physically true was to step into contested territory. But Galileo's strength lay in his refusal to separate mathematical clarity from physical reality. If the system worked better, he asked, why should it be treated as fiction? The question was not rhetorical. It was structural. He had already seen too many cases where accepted authority failed to match observation. The Copernican model began to appear to him less like speculation and more like a framework that aligned with what the telescope was revealing. Still, adopting it fully meant confronting a deeper resistance than academic disagreement. It meant challenging a worldview in which Earth's centrality was tied not only to science, but to meaning itself. The emotional weight of that shift cannot be overstated. To suggest that Earth moved was not simply to relocate a planet. It was to displace humanity from the symbolic center of creation. It was to suggest that the universe did not arrange itself around human existence in the way tradition had long assumed. Galileo understood that such an idea would not be received as neutral correction. It would be interpreted as disruption, and yet the evidence he had gathered did not bend easily toward Earth-centered explanations. The patterns of Jupiter's moons, the imperfections of the sun, the roughness of the moon, all of it began to align more naturally with a cosmos in which Earth was not unique in its motion. What made this moment particularly charged was not just the idea itself, but the transition Galileo was undergoing. He was moving from observer to interpreter, from interpreter to advocate, from advocate to public voice. The Copernican model in his hands was no longer just a mathematical curiosity. It was becoming a coherent picture of reality. That transition changed everything, because once a model stops being hypothetical and starts becoming descriptive, it enters the world of consequences. Galileo did not yet fully abandon caution. He understood the risks of declaring such a position too aggressively. The institutions that shaped intellectual life in Europe were not only academic, they were also theological and political. To challenge cosmology was to step into a space where knowledge, authority, and belief overlapped. But the direction of his thinking had already shifted. He was no longer asking whether Copernicus might be right in abstract terms. He was asking whether the universe, as observed through the telescope, was quietly confirming a truth that older systems had failed to recognize. And that question, once formed, could not easily be reversed, because it implied something even more profound than a moving Earth. It implied that truth might exist independently of tradition, and if that were true, then the entire structure of inherited certainty, philosophical, educational, and spiritual, would need to be reconsidered. Galileo was not only approaching a scientific revolution, he was approaching an epistemological one, a shift in how knowledge itself was justified. And that shift would not remain confined to mathematics or astronomy for long. It would enter public life. The Copernican idea had not yet become a public declaration from Galileo, but it had already become a private conviction shaped by observation. The universe he was uncovering through his telescope no longer fit comfortably within the older, Earth-centered framework. Each discovery tightened the gap between inherited explanation and observed reality. But ideas, no matter how carefully reasoned, do not exist in isolation. They travel through people, institutions, and reputations. And as Galileo's confidence in a new cosmic structure grew, so too did his visibility in intellectual circles. Visibility, however, is never neutral. The more widely his observations spread, the more they began to attract attention not only from fellow scholars, but from those responsible for guarding the boundaries of acceptable thought. What had begun as a set of astronomical discoveries was about to become something far more personal and far more politically charged. A public argument over who had the authority to define the structure of reality itself. And in that transition, Galileo would discover that the universe was not the only thing capable of resistance. Galileo did not become controversial because he stopped observing. He became controversial because he stopped staying quiet. By the time his ideas about the heavens had taken shape, he was no longer a distant academic recording private curiosities in notebooks. He was a visible intellectual figure in Italy, someone whose reputation had begun to travel faster than the telescopes he refined. People did not only discuss his discoveries, they discussed him, his confidence, his tone, his certainty. These became part of the story as much as the moon's mountains or Jupiter's companions. And Galileo understood something that many of his contemporaries preferred not to admit. Ideas do not move through the world on evidence alone. They move through language, personality, persuasion, and force of presence. He had all of those in abundance. When he spoke or wrote about his observations, he did not always adopt the cautious, deferential tone expected of a scholar dealing with inherited authority. Instead, he wrote with clarity that bordered on challenge, as if the universe had already been questioned long enough and now simply needed to be described correctly. This style made him compelling to supporters and exhausting to opponents. In private intellectual circles, debates around his work began to sharpen. Some scholars admired the precision of his observations, but hesitated at the implications he drew from them. Others felt that he moved too quickly from what was seen to what was concluded. Still others recognized that even if they disagreed with his interpretations, they could no longer ignore the instruments he used or the evidence he presented. The telescope had changed the terms of discussion, but Galileo had changed the tone. And tone matters in moments of intellectual transition. He was not simply reporting anomalies anymore. He was building an argument about the structure of reality. And that argument, increasingly, pointed away from Earth-centered models toward a universe that was more dynamic, less hierarchical, and far less accommodating to inherited assumptions. This is where Galileo's personality became inseparable from his work. He was not a neutral figure in the modern sense. He was engaged, he argued, he corrected, he pushed. He sometimes mocked positions he considered weak. This made him effective in some contexts and deeply unsettling in others. In an age where intellectual authority was closely tied to institutional respect, Galileo's refusal to soften his conclusions created friction that could not easily be smoothed over. There is a particular tension that runs through this phase of his life, the gap between what he believed he was doing and what others believed he was doing. From Galileo's perspective, he was simply following evidence. The universe had revealed patterns, and those patterns demanded explanation. From the perspective of some of his critics, however, he was not merely describing the world, he was undermining a shared structure of meaning. That difference in interpretation would become increasingly important. As his work spread, Galileo also became more adept at securing support from powerful patrons. In Renaissance Italy, intellectual survival often depended on such relationships. A patron could provide protection, resources, and legitimacy. Galileo understood this system well and navigated it with careful attention. But patronage was not a shield against controversy. It was a network within it. The more visible he became, the more his ideas were drawn into broader conversations about authority, education, and interpretation of nature. What began as astronomical observation increasingly intersected with questions about philosophy and theology. At the center of all this stood a growing tension. Galileo's belief that nature could be understood through direct observation versus a tradition that treated established interpretation as the primary path to truth. The telescope had given him a new kind of sight, but sight alone was not enough to change consensus. Consensus required trust, and trust was not distributed evenly in Galileo's world. Still, he continued, because once a pattern has been seen clearly enough, it becomes difficult to pretend it is not there. And Galileo had seen too much to easily return to silence. The more he spoke, the more attention he attracted. The more attention he attracted, the more his ideas became symbols rather than just arguments. And symbols, unlike observations, do not remain neutral. They are embraced, resisted, or fought over. Galileo was no longer just describing the heavens. He was becoming part of a larger struggle over how the heavens could be described at all. Galileo's growing prominence changed the scale of his conflict. What had begun as a series of telescopic discoveries and mathematical arguments was no longer confined to scholarly discussion. His ideas were now circulating in a world where intellectual authority was closely tied to religious interpretation, institutional power, and political caution. This expansion of attention brought new scrutiny, not just of his observations, but of what those observations seemed to imply about the structure of reality and humanity's place within it. The question was no longer only whether his claims were correct. It was whether those claims could be safely absorbed into the existing order without destabilizing it. And as Galileo's confidence in his conclusions deepened, so too did the concern of those responsible for guarding the boundaries of accepted thought. Next, we move into that widening circle of scrutiny, where ideas cease to be purely intellectual and begin to acquire consequences beyond the page or the telescope, where Galileo's work is no longer simply studied, but watched. At first, Galileo did not feel as though he was crossing into danger. He felt as though he was clarifying something that had always been there. The universe, as he saw it through observation, was not collapsing into chaos. It was revealing structure, just not the structure inherited from ancient authority. The moon's uneven surface, the sun's shifting marks, Jupiter's companions, the motion implied by Copernicus. All of it pointed toward a cosmos governed by physical consistency rather than philosophical hierarchy. But in 17th century Italy, clarity was not always the same thing as safety. As Galileo's reputation grew, so did the number of eyes watching him. Universities, scholars, religious thinkers, and court intellectuals all began to take an interest in what exactly he was claiming about the nature of the heavens. At first, this attention was not hostile. It was curious, even admiring. His telescopic discoveries were difficult to dismiss outright because they could be verified by others who were willing to look. That was part of what made him so unsettling. He was not asking people to believe him blindly. He was asking them to look for themselves. And that request, simple as it sounded, had profound implications in a world where truth was often mediated through interpretation rather than direct observation. If individuals could confirm astronomical reality with their own eyes, then authority no longer held exclusive control over what counted as knowledge. This shift began to create unease in certain circles. The issue was not that Galileo had found imperfections in the heavens, it was what those imperfections seemed to suggest when placed together. If celestial bodies were not fundamentally different from Earth, and if Earth itself moved, then long-standing interpretations of cosmic order required revision. And if cosmic order required revision, then broader philosophical and theological frameworks built upon it might also need reconsideration. This is where Galileo's work began to leave the domain of astronomy alone and enter the realm of meaning. He continued to publish and discuss his findings with growing confidence. He wrote in a style that emphasized observation over inherited authority, often framing his arguments in ways that suggested nature itself could correct traditional interpretation. To his supporters, this was refreshing. To his critics, it was provocative. The tension was not merely intellectual. It was institutional. In Galileo's world, knowledge did not exist in isolation from authority. Universities, religious institutions, and political structures were deeply intertwined with how reality was explained and taught. A shift in cosmology was never just a shift in science. It had implications for education, doctrine, and the legitimacy of interpretive frameworks that had shaped Europe for centuries. This is why Galileo's growing prominence could not remain purely academic. His ideas were increasingly discussed not only in scholarly rooms, but in broader contexts where questions of orthodoxy and interpretation mattered deeply. And as that happened, the tone around him began to change subtly. What had once been curiosity began to include caution. What had once been admiration began to include scrutiny. Galileo, for his part, did not present himself as someone retreating from his conclusions. He was convinced that careful observation, repeated consistently, revealed a universe that did not align with strict Earth-centered models. He saw himself as working within a method that relied on evidence rather than inherited assumption. But others were not only evaluating his method, they were evaluating his implications, and implications are often where intellectual disputes become personal. As discussions around his work spread, Galileo found himself increasingly positioned not just as a scientist or mathematician, but as a figure whose interpretations carried broader significance. That shift mattered. It meant that disagreement with him was no longer simply disagreement about data. It could be interpreted as disagreement about deeper principles of order and truth. This was the beginning of a more complex phase in his life. He was no longer simply observing the heavens. He was now part of a widening conversation about how the heavens should be understood, who had the authority to define that understanding, and what it meant when observation began to challenge long-standing interpretation. The telescope had opened the sky, but it had also opened a question that could not easily be closed again. Galileo's growing visibility and the expanding implications of his work had moved him into a space where intellectual debate was no longer confined to academic exchange. His ideas now existed within a network of authority, interpretation, and institutional concern. What began as a series of careful observations had become part of a larger question about how truth itself should be defined and who had the right to define it. As attention intensified, so did the seriousness with which his claims were examined. The discussion was no longer only about what he had seen through his telescope. It was about what those observations meant for established understandings of the cosmos, and whether those meanings could be reconciled with existing frameworks without destabilizing them. In this atmosphere, disagreement could no longer remain abstract. It began to take shape in formal review, structured questioning, and institutional response. And Galileo, who had once looked quietly into the night sky seeking clarity, now found himself moving toward a confrontation where observation, authority, and interpretation would collide directly, and where the consequences would no longer remain confined to ideas alone. There is a particular kind of silence that forms when ideas stop being discussed and start being judged. Galileo encountered it not in the night sky, not in his telescope, and not in the quiet moments of observation, but in rooms where his words were no longer treated as discoveries, but as declarations that required examination. The shift was subtle at first, almost procedural. Questions replaced curiosity. Curiosity hardened into scrutiny. Scrutiny narrowed into accusation. What had begun as a series of observations about the heavens was now being treated as something heavier, a challenge to how reality itself should be interpreted. Inside those institutional spaces, Galileo was no longer simply Galileo the mathematician or observer. He was Galileo the claimant, Galileo the interpreter of the cosmos. Galileo whose conclusions carried implications that reached beyond astronomy into the deeper structure of belief and authority. The tension that had been building for years finally condensed. At the center of it was a simple but explosive issue: whether the Earth moved. To Galileo, the answer was increasingly clear, supported by patterns that repeated across his observations. The motions of Jupiter's moons, the imperfections of celestial bodies, the mathematical elegance of a sun-centered system, all of it pointed toward a universe that did not revolve around Earth in the way tradition had long insisted. But clarity of evidence does not automatically translate into acceptance. In the formal inquiries that followed, Galileo was not only asked what he had seen, he was asked what those observations meant, how they should be interpreted, and whether they could be reconciled with established frameworks that had shaped generations of thought. This is where the conflict deepened. Because Galileo's method was rooted in direct observation, while the institutions examining his claims were rooted in interpretive authority. He trusted what could be seen, measured, and repeated. They carried the weight of systems that had organized knowledge long before telescopes existed. The disagreement was not only about astronomy, it was about how truth itself should be established. In such an environment, words carried consequences beyond their immediate meaning. A statement about planetary motion could be understood as a statement about human place in the universe. A model of the cosmos could be interpreted as a challenge to inherited structure. Even careful phrasing could not fully contain the tension between observation and tradition. Galileo, for his part, did not present himself as someone abandoning reason or caution. He attempted to argue within the language of his time, using evidence, demonstration, and comparison. But the space he was moving through had changed. It was no longer a neutral exchange of ideas. It was a field of boundaries, what could be said, what could be defended, and what could be safely accepted. The process that unfolded around him was not simply scientific. It was procedural, institutional, and deeply tied to the preservation of interpretive order. His ideas were evaluated not only for their internal coherence, but for their broader implications. And implications, once they reach that level of attention, rarely remain abstract. Eventually, Galileo was asked to account for the positions he had taken, to clarify the distinction between mathematical models and physical reality, and to explain how his interpretations fit within accepted frameworks of understanding. What followed was not a sudden collapse, but a tightening space. His freedom to argue became narrower. His ability to present conclusions became more constrained. The conversation around him shifted from exploration to boundary setting. In that tightening space, Galileo experienced one of the most profound transitions of his life, the realization that evidence alone does not determine acceptance when acceptance is tied to deeper structures of authority and meaning. The room in which he found himself was no longer simply a place of debate. It had become a place where ideas were being weighed not only for their accuracy, but for their consequences. And Galileo, who had spent his life trusting the clarity of observation, was now facing the limits of what observation alone could accomplish in a world structured by interpretation. The trial of ideas was no longer theoretical. It was unfolding in real time, and its outcome would reshape not only his life, but the trajectory of how humanity would come to understand the relationship between knowledge and authority. The formal scrutiny surrounding Galileo did not end the questions his work had raised. Instead, it marked a turning point where those questions could no longer remain within academic or observational spaces. What had begun as a quiet revolution of seeing had entered the domain of institutional judgment, where ideas were no longer just evaluated. They were contained, directed, and constrained. For Galileo, this meant a fundamental shift in his position. He was no longer primarily an observer of the universe. He was now a figure whose interpretations were subject to limits imposed from outside his instruments and his methods. The consequences of that shift would soon become personal in a way that observation alone could not prepare him for. And as the structure around him tightened, the next stage of his life would reveal what happens when a mind trained to trust evidence must continue its work under conditions where expression itself becomes restricted and where the pursuit of truth must adapt to confinement rather than freedom. When the verdict of power finally settled around Galileo, it did not arrive like a thunderclap. It arrived like a closing door. The universe he had spent so many years describing did not vanish. The moon did not lose its mountains. Jupiter did not stop carrying its wandering companions. The sun did not smooth itself into perfection. Reality remained exactly what it had been. What changed was Galileo's position inside it. The man who had once looked outward with such confidence now found himself living under limits imposed by others. House arrest was not a dramatic prison in the common imagination. There were no iron bars cutting the light into pieces. No public chains dragged through streets. But for a mind like Galileo's, confinement had another kind of cruelty. It narrowed the world. It cut him off from the direct freedom of movement that had made his earlier life so productive. It turned the horizon inward, and yet even this could not stop him. This is one of the most remarkable qualities of Galileo's later life. The scale of his restraint and the scale of his mind became almost absurdly mismatched. Physically, he was contained. Intellectually, he remained restless. The same mind that had once refined lenses and tracked lunar shadows now turned toward memory, mechanics, motion, and the deeper foundations of scientific reasoning. The sky had brought him fame, but confinement pushed him back toward the earthbound laws that governed everything from falling bodies to the arc of a thrown object. There is a quiet dignity in this stage of his life, but also something more tragic. He was older now, stronger in thought than in body, more certain in some ways and more vulnerable in others. His reputation had been transformed into a symbol. His name had become larger than his person. But the man himself still had to wake up each day inside the same house, beneath the same walls, with the knowledge that he could no longer walk freely through the world he had helped change. Even so, the work did not stop. He continued to think, correspond, and refine ideas that would later feed into the broader development of mechanics and physics. His later writing carried a different rhythm than his earlier observational triumphs. The excitement of revelation remained, but it was now joined by reflection, consolidation, and a hard-earned clarity about how nature behaved. In this period, Galileo was not chasing new celestial shocks. He was distilling a method of understanding the physical world that would outlast the controversy surrounding his name. That method mattered as much as any single discovery, perhaps more, because in the end, Galileo's greatest legacy was not only that he looked at the heavens and saw what others had missed. It was that he helped teach a civilization how to trust observation, measurement, and mathematical description in a new way. He made it harder to confuse repetition with truth. He made it harder to rely on authority alone. He made the act of looking feel morally serious. The irony is unavoidable. The man constrained by institutional judgment helped create a future in which ideas could travel farther and faster than institutions could contain them. From his house, he could not influence the world by force. But his ideas did not require force. They were already moving outward in quieter, more durable ways. Students, readers, and later thinkers absorbed them. Observational science became less a private art and more a public expectation. The telescope itself became one of the symbols of that shift, but the deeper transformation lay in attitude. Galileo had made it intellectually respectable to let nature disagree with tradition. That was his defiance. Not loudness for its own sake, but persistence. Not rebellion as theater, but fidelity to what he had seen. And because of that fidelity, the silence imposed on him could never be absolute. A person can be confined without being erased. Galileo's body was restricted. His influence was not. As his sight began to fail, the irony deepened. The man who had extended human vision into the heavens was slowly losing his own. But even that carried a strange emotional force. It made his life feel almost emblematic, as though the act of seeing clearly had exacted a cost from the vessel that made it possible. Still, the ideas remained. The sky still held its layered complexity. The planets still moved. The Earth still circled the sun. Time kept its own patient rhythm. And Galileo, though increasingly reduced in physical freedom, remained intellectually alive within that changing world. He had been made smaller in one sense, but his work and the future it helped create grew larger in proportion. That is how silence failed him. Not by ending the story, by leaving the story far too powerful to stop. Galileo's confinement marked the end of one kind of conflict, but not the end of his significance. The immediate battle over his ideas had been decided within the structures of authority, yet the deeper consequences of his work had already escaped those boundaries. The questions he raised about motion, observation, and the nature of the cosmos were no longer contained in his lifetime. They were entering the long historical future. What he had done could not be undone. The universe would never again be imagined quite the way it had before his telescope, his notebooks, and his stubborn refusal to accept appearances as final truth. Outward from the walls of his house to the much wider horizon of history itself, tracing how Galileo's ideas traveled into later centuries and helped build the foundations of modern science, where the consequences of one man's seeing became part of the way an entire civilization learned to understand reality. Galileo spent the final stretch of his life in a world that was still learning how to understand him. While he remained under constraint, the intellectual currents he had helped unleash continued to spread far beyond the rooms where he had once argued, demonstrated, and defied convention. His life had become smaller, but his influence had become larger. That is one of history's strangest reversals. The body can be confined, while the mind escapes into generations that have not yet been born. What Galileo had changed was not just astronomy. He had changed the habits of thought that made modern science possible. He had insisted again and again that nature could not be understood by reverence alone. It had to be observed, tested, measured, and returned to until it gave up a pattern. That approach did not erase wonder. It gave wonder a method. The importance of that shift can be seen if the story is widened for a moment into a simple timeline. First came the old universe, held together by inherited authority and philosophical tradition. Then came Copernicus, who offered a sun-centered model in mathematical form. Then came Galileo, who aimed the telescope at the sky and made the heavens physically answer back. After him came the later builders of physics, who inherited not just his conclusions, but his example. Newton, with his laws of motion and gravity, and the generations that followed, each pushing further into the architecture of the natural world. The chain matters. Galileo was not the end of the revolution. He was one of the moments when the revolution became irreversible. His observations helped alter the center of the human imagination. Once people had accepted that Earth was not the still heart of the cosmos, everything else had to be reconsidered. Distance, motion, size, place and perspective all took on new meanings. The sky became measurable. The planets became physical worlds. The universe became something that could be investigated rather than merely interpreted from a distance. The language of that future is easy to imagine. A diagram with Earth fixed at the center, a Copernican chart with the sun in the middle, a telescope sketch aimed upward, a timeline stretching from Galileo's night observations to Newton's equations, and then onward to modern observatories, spacecraft, and lunar landings. Each image tells the same story in a different register. The center has moved. Humanity has had to move with it. That shift had consequences far beyond astronomy. Galileo helped define a new attitude toward truth itself. He made it harder to claim that knowledge was complete simply because it was old. He helped make doubt respectable when doubt was tied to evidence. He made it more reasonable to ask whether a beloved explanation might still be wrong. In doing so, he did not weaken reason. He strengthened it by forcing it to answer to reality. This is why Galileo's legacy feels larger than his life. He became part of the foundation under the modern world. Laboratories, telescopes, physics, engineering, and even the basic expectation that claims should be tested before being accepted all owe something to the way he approached the heavens. He taught later generations that a person does not honor creation by refusing to look closely at it. A person honors it by looking until it begins to tell the truth. Yet his influence was not purely scientific. It was also human. He became a symbol of the difficult relationship between insight and power, between what can be seen and what institutions are willing to admit, between the courage to state a truth and the cost of doing so too early. That is why his story has lasted. It is not only about a telescope. It is about what happens when a mind refuses to shrink itself to fit the world's comfort. In that sense, Galileo's legacy lives in every act of serious observation. It lives in every person who chooses evidence over convenience. It lives in every scientist who trusts measurement over rumor, and in every student who learns that certainty without examination is only a costume worn by error. His life ended in constraint, but his thought escaped. And perhaps that is the deepest form of victory history can offer. Not freedom for the body, but permanence for the idea. Galileo's name now belongs to the architecture of knowledge itself. It stands beside the moon he studied, the sun he examined, and the moons of Jupiter that once moved silently across his notebook pages. The universe he discovered was not tidy, and that was precisely its glory. It was larger than tradition had allowed, stranger than comfort had expected, and more beautiful because it refused to remain simple. By the time Galileo's influence had spread into the centuries beyond his own, the question of whether Earth moved had become almost ordinary. What once threatened the old order had been absorbed into the new one. The conflict that had defined so much of his life now appeared in hindsight as the opening of a door that could never again be closed. But his story still leaves one more question behind, and it is the question that makes the whole life feel larger than a scientific biography. If the universe changed because one man looked at it differently, then what exactly was the price of seeing clearly before everyone else was ready? The historical consequence reveals a deeper meaning of Galileo's life. It asks what his story reveals not only about astronomy or science, but about courage, loneliness, pride, and the strange burden of being right at the wrong time. By the time Galileo's ideas had settled into the intellectual fabric of Europe, the world he had known was already fading into history. What had once been controversial was becoming familiar. What had once been shocking was becoming textbook knowledge. The Earth moving around the sun, the imperfections of the heavens, the idea that observation could correct authority, these were gradually absorbed into a new way of thinking that no longer felt dangerous, only obvious. But Galileo himself never lived in that obvious world. For him, the cost of seeing had been real, immediate, and irreversible. His life raises a question that does not belong only to astronomy or science. It belongs to every era in which knowledge changes faster than acceptance. What does it mean to be right before the world is ready to be wrong? Galileo's story is often told as a victory of truth over ignorance, but that framing misses something essential. Truth did not arrive cleanly. It arrived with resistance, misunderstanding, caution, and fear. The same evidence that now seems clear once required courage to even display. The telescope did not simply reveal the universe. It revealed how difficult it is for human systems to adjust when their foundations are touched. And Galileo stood at the center of that tension. He was not a passive figure swept along by discovery. He was active, sometimes impatient, often convinced, occasionally confrontational. He believed that nature, once carefully observed, would eventually force agreement. In that belief, there was brilliance, and also a certain blindness to how deeply people are attached to inherited structures of meaning. Because the issue was never just whether the Earth moved, it was what that movement implied. If Earth was not the center, then humanity was not the center. If celestial bodies were not perfect, then perfection was not the dividing line between heaven and earth. If observation could correct tradition, then authority could no longer claim final word over truth. Each of these implications extended far beyond astronomy. Each one touched identity, belief, and power. That is why Galileo's discoveries created friction that could not be resolved by data alone. He lived inside that friction, and so the question that follows him through history is not simply, was he right, but something more unsettling. What does it mean to be right in a world that cannot yet absorb what rightness requires? There is a loneliness in that position that is easy to overlook. Galileo was admired, criticized, defended, and condemned at different moments, but the experience of seeing something clearly before others do is inherently isolating. Even when others eventually come to the same conclusion, they do so from a different time, with different assumptions, and without the same weight of resistance. In that sense, Galileo never fully arrived in the world that later adopted his ideas. He lived and died in the transition between worlds, the moment when one universe was still defending itself and another was still forming its language. This is what gives his story its lasting emotional force. It is not only about discovery, it is about timing, about the distance between seeing and acceptance, about the human cost of clarity, and about the strange fact that knowledge, even when correct, can arrive too early for comfort. Galileo's life, viewed this way, becomes less a tale of triumph and more a portrait of transformation under pressure. A mind expanding against the limits of its time, a voice insisting on what could be seen, a person caught between the certainty of observation and the uncertainty of reception. In the end, what remains is not only his discoveries, but the shape of his effort, the refusal to look away, the decision to trust what the instruments revealed even when the world demanded restraint, the willingness to let evidence stand even when it threatened stability. That is the deeper inheritance he left behind. Not just a changed cosmos, but a changed expectation of how truth enters the world. After Galileo, the sky could no longer be the same kind of sky. It was no longer a polished emblem of perfection suspended above a separate Earth. It had become a shared physical space, measurable, imperfect, structured by laws that applied everywhere. The universe had grown larger in scale, but also closer in kind. What existed above was no longer fundamentally different from what existed below. Yet even as this new understanding took shape, the older world did not disappear completely. It lingered in language, in imagination, in the slow adjustment of institutions and belief. Change of this magnitude does not happen all at once. It settles gradually, like light spreading across a landscape after sunrise. Galileo did not live to see the full shape of the world he helped create. But his story continued to move forward without him, carried by those who built upon his method, expanded his observations, and refined his vision of a universe governed not by inherited certainty, but by evidence patiently gathered and carefully understood. And so the final question remains, not about the sky itself, but about the act of looking upward and realizing that what appears fixed may still be waiting to be redefined. In the end, Galileo Galilei's story is not really about a telescope. It is about what happens when the act of looking becomes powerful enough to challenge the way a civilization understands itself. Before him, the sky was often treated as something final, complete, perfect, already explained. After him, it became something open, measurable, testable, and still full of unanswered structure. The difference is subtle in language but enormous in consequence. One universe asks for contemplation, the other demands investigation. Galileo lived through the moment when that shift became irreversible. He did not simply add details to an existing picture of the cosmos. He changed the rules for how the picture could be drawn at all. The moon stopped being a symbol of perfection and became a landscape. The sun stopped being a flawless emblem and became a rotating body with visible change. Jupiter stopped being just another point of light and became a system with its own companions. Earth stopped being the assumed center and became one world among others, moving through a larger order that did not revolve around human expectation. Each of these discoveries, taken alone, might have been absorbed into older frameworks. Taken together, they formed something harder to contain, a universe that no longer fit neatly inside inherited certainty. But the deeper legacy of Galileo is not only what he saw, it is how he insisted on seeing. He helped establish a habit of mind that would shape centuries that followed. The idea that nature can be questioned directly, that observation can correct authority, and that truth is not weakened by testing. It is revealed through it. That habit did not remove disagreement from the world. It made disagreement more precise. It moved conflict away from blind acceptance and toward evidence, method, and interpretation. At the same time, his life also reveals something more human and more difficult. Seeing clearly does not guarantee being understood clearly. Knowledge can arrive early. Evidence can outpace acceptance. And individuals who stand at that gap between what is seen and what is believed often carry a burden that is not purely intellectual. Galileo's confinement in later life is often remembered as a symbol of suppression, but it is also a reminder that ideas do not require permission to survive. While his physical world narrowed, his intellectual influence widened. His observations did not retreat with him. They moved forward, carried by others who refined, expanded, and eventually normalized what had once seemed impossible. That is how change in knowledge often works. Not as a single moment of victory, but as a gradual adjustment in what a culture is willing to see without turning away. Centuries later, the universe Galileo helped reveal feels familiar. The Earth moving through space is not a shock. The imperfections of celestial bodies are not scandalous. The idea that observation refines understanding is foundational, but that familiarity can sometimes hide how difficult the transition once was and how much it required from those who stood at its beginning. Galileo's life sits at that beginning. Not as a perfect hero, and not as a simple victim of ignorance, but as a mind caught in the pressure between what had always been believed and what was beginning to be seen too clearly to ignore. And that is why his story endures. Because it is not only about the sky changing. It is about what happens when a single human being looks at the world carefully enough that the world can no longer remain the same. Thank you for watching. If you enjoyed this journey into the past, be sure to like the video, share it with fellow history enthusiasts, and subscribe for more deep dives into the people, civilizations, battles, myths, and moments that shaped our world. Leave your thoughts and theories in the comments below. Your perspective might inspire a future video. Until next time, keep exploring history because the past is never truly gone.